Welcome students to the another new lecture of the engineering chemistry course. As we are started with the unit 3rd corrosion and control of the corrosion. So before going to the today's lecture, just revise what we have learned in our previous class. In our last class, we have started with the topic types of corrosion, in which three important types of corrosion we have discussed in detail: the galvanic corrosion, differential aeration or concentration cell corrosion, and the pitting corrosion. These all types of corrosion we have discussed in detail in our previous class. Today we are going to start a new topic, corrosion control, in which we are going to discuss about the various methods for corrosion control. Among the various methods of corrosion control, three important methods we are going to discuss in the today's class. What are these methods? Appropriate designing, modification of environment, and use of corrosion inhibitors. So let us begin with the topic corrosion control or protection from corrosion. Various methods used for the controlling of the corrosion are appropriate designing, modification of environment, use of corrosion inhibitors, cathodic protection or electrochemical protection method, and use of different types of coatings, in which two types of coatings we will going to discuss: metallic coatings and the organic coatings. But since corrosion cannot be completely controlled, that means corrosion control means the reduction in the rate of corrosion to minimize the corrosion. Corrosion control doesn't mean that we have to stop the corrosion 100%. No, it is never possible. Corrosion control means to minimize the rate of corrosion up to the minimum level. So, corrosion control, various types of corrosion control methods are the methods which can minimize or slower down the rate of corrosion reaction. So, it is very clear that corrosion control or corrosion protection means to minimize the rate of corrosion. It is not possible to avoid the corrosion 100%, because we know it is the chemical reaction in which metal undergoes in its oxide or whatever the compound corrosion product will be. If the metal is showing the chemical affinity towards any type of chemical reagent like oxygen, chlorine, H2S, then the metal must undergo in this type of reactions. Therefore, corrosion reaction must have to take place. But what we want here in corrosion control methods, that the rate of reaction of these type of product formation will be minimized. So corrosion protection means to minimize the rate of corrosion reaction up to the minimal level. So let us begin with the various type of corrosion control method. First is the appropriate designing. In the last class, we have discussed about various types of the corrosion. So we know that the different type of conditions in which metal undergoes corrosion faster. So as we know the different type of condition in which corrosion rate may increase, so we can minimize the rate of corrosion accordingly. So first we are discussing here the appropriate designing. Proper designing of an object, metallic object, helps in prevention of corrosion. How? The first point is, the contact of the two dissimilar metal must be avoided. In our last class, we have discussed that when two different metals are in direct contact, then corrosion chances may increase. So, first we have to avoid the direct contact between two dissimilar metals. If this direct contact is unavoidable, then what precautions should be taken? First, if direct contact is unavoidable, then anodic area should be very large as compared to cathodic area. That means if it is not possible to avoid the direct contact between two dissimilar metals, then we should choose metals in such a way that the more reactive metal, that means the anodic metal, should be large, while the less reactive metal should be small. That means anodic area should be large and cathodic area should be small, because in the last class we have discussed that the anodic area is inversely proportional to the rate of corrosion reaction. So as the anodic area will be the larger, the rate of corrosion will be smaller. That's why we should choose the metal, we should select the metal in such a way that anodic metal should be large while cathodic metal should be smaller. Thirdly, if direct contact is unavoidable, then we should use the different type of metal in such a way that these metals, the difference in the electrode potential of these two metal is minimum. That means two different metal used in the structure should be such that they are occupying near position in the galvanic series, so that the electrode potential of two different metal will be less. As in our last class we have discussed, the as the electrode potential difference of two dissimilar metal will be high, the rate of corrosion will also increases. So we should select the metal in such a way that their position in the galvanic series will be near, so that electrode potential difference between these two metal is smaller. If direct contact is unavoidable, then we should place the proper insulator between the two dissimilar metals, just like we are using the rivets, plastic or rubber rivets between two metallic structures. So we can use any insulator between two dissimilar metals. So one aspect of the designing is we should choose designing in such a way that a single metal is used in the designing. If it is not possible that a single metal completely design any equipment, then we should choose two different metals in such a way that anodic metal should be large and cathodic metal should be smaller. Secondly, the difference between electrode potential of these two metals should be as small as possible. That means both the metals are chosen in such a way that in galvanic series they are very near, so that the electrode potential difference between these two metals is minimum. Third, if two different metals are used, then we should use proper insulation between these two metals. Clear? This is about the two different metal used in the particular equipment or the particular apparatus. So if a single metal is used, so this single metal should be the extremely pure metal, because if impurities are present in the metal, then these presence of these impurity causes the chemical non-uniformity, and due to the chemical non-uniformity, metal undergoes in the corrosion. So if a single metal is used, then it should be extremely pure. Similarly, if we are using the alloy, then this alloy should be homogeneous alloy. No heterogeneity should be there in the alloy, because if there heterogeneity in the alloy, then it will cause the stress in the alloy, and due to this stress chemical non-uniformity creates, and this will cause the corrosion. So basically what we have learned till now, that we should avoid the direct contact between two dissimilar metals. If direct contact is unavoidable, then we should select the metal in such a way that in galvanic series the difference in the electrode potential of these two metal should be the minimum, and anodic metal should be large and the cathodic metal should be small. and direct contact can be avoided by the using of the proper insulation between these two metal. These points are related to the case when two dissimilar metals are used in the designing of any type of structure. If a single metal is used, then this metal should be in the extremely pure condition to avoid the chemical non-uniformity. And in case alloy is used, then this alloy should be completely homogeneous alloy. So this is about the metals used for the designing of any type of structure. Third important aspect of the appropriate designing is that design or fabricate equipment or metal parts in such a manner that they have minimized sharp edges and corners. Why sharp edges and corners? Because as we discussed in the last class, suppose one structure is this type of sharp edge and one structure in curved edge. So in the curved parts, cleaning is very easily possible, and in the sharp corner points there is the accumulation of the dust particle possible. So here if dust particles are accumulated, so differential aeration corrosion chances may increases. While in this type of curved corner structures proper cleaning is possible, so no deposition of the dust or dirt particle takes place in this type of structures. Therefore differential aeration corrosion chances we can minimize. So the structures are in such a way that sharp edges and corners must have minimized, and as far as possible we should avoid the crevices in the joints. Suppose we want to join these type of two metallic structure, if we are using different bolts to join these two metallic structures, then there is the possibility to form the crevices between these. And we know if crevices are there, then chances of the pitting corrosion and the rate of corrosion will be increases. While if we are using these structures through the welding, then it is the good design because no crevices is there. So differential aeration corrosion is we can minimize in this way. So by using proper designing we can minimize the corrosion. Similarly, one more example here for the designing, that in this figure the equipment is placed at the base, but in this structure the equipment is supported by the stand or the legs. So in second case, this is the second case, this is the first case. So in the second case the proper air circulation is possible because we are using here the stand. So due to the proper air circulation all around the metallic structure, air concentration is same, uniform, while in such first case different air concentration at the metallic surface is there. First is the A part where air oxygen concentration is high, second is the B part where air or oxygen concentration is low. So due to this differential aeration corrosion may takes place in this design. So it is considered as the poor design with respect to the rate of corrosion. So by appropriate designing of the metallic structures we can minimize the rate of corrosion. Okay. Now second point to control the corrosion is the modification of the environment. We know that the corrosion is the reaction in which surrounding environment attacks on the metallic surface. So we can minimize the corrosion rate by modifying the surrounding environment of the metal. And what modifications we have to do? First is the deaeration, second deactivation, third dehumidification. So remember 3 D's. What 3 D's are? Deaeration, deactivation and the dehumidification. Deaeration means removal of the air or oxygen from metal surface. Deactivation means inhibition of the chemicals at the metal surface, deactivation of the chemicals. And dehumidification means removal of the water or moisture content from the metal surrounding. So deaeration, that means removal of oxygen at the metal surroundings. This can be done by adjusting temperature and the mechanical aging. So by mechanical methods or by increasing the temperature, we can remove the oxygen or air from the surrounding of the metallic surface. Second is the deactivation. Deactivation involves addition of chemicals such as sodium sulfite and hydrazine. Basically, these chemicals absorbs the oxygen. So, if oxygen is removed from the metallic surface, then corrosion chances can be minimized. Third is the dehumidification. Dehumidification of environment is done by adding alumina or silica gel. Basically, these substances absorbs the moisture from the surrounding, and when the substances absorbs the moisture, that means dehumidification is done at the metallic surfaces. So by these ways we are removing the chemicals from the metal surroundings, and once the chemicals, oxygen or air or water is removed from the metallic surface, then corrosion chances can be minimized. Third important point to minimize the corrosion is the use of corrosion inhibitors. Basically, the corrosion inhibitors are the substances which are used to minimize the rate of corrosion reaction. Now, as we discussed in detail the mechanism of corrosion in our previous classes, so we know that the corrosion reaction involves basically the two types of reaction. One is the anodic reaction, second one is the cathodic reaction. So these half cell reactions combinedly results in the complete corrosion reaction. So if we can minimize or if we can control one type of reaction, then other type of reaction automatically minimized. So overall corrosion rate is slower down. So on the basis of the reaction which is minimized or which is slower down, the anodic or cathodic inhibitors are the two types of the corrosion inhibitors. Since we know that the overall corrosion reaction is the combination of two types of reaction, anodic reaction and the cathodic reaction. So the corrosion inhibitors are also of two types, anodic inhibitors and the cathodic inhibitors. Anodic inhibitors are those chemical substances which retards the anodic reaction, that means which decreases the rate of anodic reaction, while cathodic inhibitors are those chemicals which decreases the rate of cathodic reaction. So these are the inhibitors which specifically decreases the anodic reaction, and these are the inhibitors which specifically reduces the cathodic reaction. For example, phosphate chromates of alkali and transition metals are the anodic inhibitors, while organic amines, mercaptans, thiourea and substituted urea are the example of the cathodic inhibitors. Now, let us discuss one by one each of the inhibitors. Anodic inhibitors. The anodic inhibitors are the compounds which can prevent the oxidation of anodic metal. We know that at anodic part, what reaction taking place? At anodic part, oxidation of metal takes place. So, anodic inhibitors are those substances which can retard the rate of oxidation of the metal. How can these substances react, or how can these anodic inhibitors decreases the rate of oxidation of metal? Basically, these inhibitors forms oxides or compounds with the reaction of metal. Suppose this is our metallic structure. and we are using this type some anodic inhibitor onto the metal surface. So basically these anodic inhibitors form some type of compounds like oxide or any of compound with the reaction with the metal. So on the metal surface a protective layer of the oxide or the metallic compound is formed, and this protective layer prevents the further corrosion of the metal. So in which way the anodic inhibitors react? Basically anodic inhibitors reacts with the metal, and with the reaction of the metal oxides or their compounds are formed, and these oxide forms the protective layer on the metallic surface. So in this way the anodic inhibitors prevents the metal from the further corrosion. Now these anodic inhibitors are two types, inorganic inhibitors and the organic inhibitors. On the basis of their chemical nature these are two types, anodic and the inorganic and the organic inhibitors. The inorganic inhibitors are the phosphates, chromates of alkali and the transition elements, while the organic anodic inhibitor is the sodium benzoate. That means these are the chemicals which are used onto the metal surface. Ultimately these chemicals forms the compounds with the metal structure, metal surface, and forms the protective layer onto the metal surface, and hence prevents the further corrosion. So these are the anodic inhibitors. Now cathodic inhibitors. We know cathodic inhibitors are the substances which reduces the rate of the cathodic reaction. By knowing the detailed mechanism of the corrosion reaction, we know that the cathodic reaction is highly dependent on the surrounding environment. If acidic medium is present near the metallic surface, then what reaction taking place at the cathode? At the cathode, in acidic environment, evolution of hydrogen takes place. So if we want to minimize the rate of cathodic reaction, so we have to stop the evolution of hydrogen at the cathodic part if medium is acidic. You must be remember that cathodic reaction is the medium dependent reaction. In acidic medium, cathodic reaction is the evolution of hydrogen. So if the medium is acidic, so cathodic inhibitors are different type of inhibitors. If the medium is neutral or basic, then the cathodic inhibitors are different type. Okay, so first we are considering here the acidic environment. If metal is present in the acidic environment, then at the cathode evolution of hydrogen takes place. So how can we minimize the evolution of hydrogen? By two ways we can minimize the evolution of hydrogen. That means cathodic reaction we can minimize. First, by slowing down the diffusion of the H plus ion. We know in the cathodic reaction, if medium is acidic, then what reaction taking place? These hydrogen ions combines with the electrons and form the hydrogen gas. So this is the cathodic reaction in the acidic medium. If we want to minimize this reaction, so we can do two things. What two things we can do? Suppose this is our metal surface, cathodic part, metallic surface, cathodic part, and H plus ion are there onto the metallic surface. So if we can minimize the diffusion of these H plus ion on metal surface, so if H plus ion could not come on the metal surface, then these H plus ion could not take up these electrons. So driving force of the anodic reaction will stop, because here no consumption of electron takes place. So overall corrosion reaction is minimized. So how can we minimize the diffusion of H plus ion onto the metal surface? To minimize this diffusion of H plus ion on the metallic surface, we are using the organic inhibitors. These organic inhibitors are capable of being absorbed at the metallic surface. Example, substituted urea and thiourea. As these substances, organic inhibitors, adsorbed on the metallic surface, then H plus ion could not reach to the metallic surface. If H plus ion could not reach to the metallic surface, then this reaction would not take place. That's why cathodic reaction will stop and further rate of corrosion can be controlled. Okay. Now, second aspect, how we can minimize the evolution of hydrogen or the cathodic reaction in acidic medium. We can increase the over voltage of hydrogen evolution. That means if H plus ion reached at the metallic surface, but this reaction cannot be possible due to the increased over voltage of the H plus ion. So how can we increase the over voltage? Hydrogen over voltage can be increased by inorganic inhibitors, which forms adherent film on the metallic arsenic or metallic antimony at the cathodic surface. For example, arsenic and the antimony oxide. So, cathodic inhibitors are the substances which inhibits the cathodic reaction, and we know cathodic reaction is the highly medium dependent reaction. In acidic medium, acidic environment, at the cathode hydrogen evolution takes place. So to minimize the cathodic reaction in acidic medium, we have to stop or minimize the evolution of hydrogen at cathode. How can we minimize the evolution of hydrogen at the cathode? This can be done in two ways. Either we can stop the or we can slow down the diffusion of hydrogen on the metal surface, or we can increase the over voltage of hydrogen. To minimize the hydrogen diffusion, we can use the organic inhibitors, while to increase the over voltage of hydrogen, we can use the inorganic inhibitors like antimony and arsenic oxide. So in this way, we can minimize the cathodic reaction in the acidic medium. But in case the medium is neutral or the basic, we know neutral or basic, in the neutral or the basic medium, what cathodic reaction takes place? This cathodic reaction takes place in which absorption of oxygen takes place, and due to this absorption of oxygen, further what generation? Hydroxyl ions generates. This reaction we will discuss again. Okay, this is the cathodic reaction in the neutral medium. Generation of the OH minus ions, hydroxyl ion, and the absorption of the oxygen gas. So if we want to stop this reaction, either we stop the oxygen absorption or we can stop the generation of the OH minus ions. So how can we control this? First, we can eliminate oxygen from the corroding medium. If this is our cathodic part of the metallic surface, if oxygen could not reach at the metallic surface, then this reaction would not happen. So first we can do that the elimination of the oxygen from the surrounding medium. This oxygen is eliminated by using deaeration method or by using the reducing substances like sodium sulfite. These can react with oxygen and oxygen will remove from the metallic surroundings. Second, by slowing down the diffusion of oxygen to cathode. This is the removal of the oxygen. And second point is the slow down the diffusion. That means oxygen is there, but the diffusion of oxygen to the metal surface is slowed down. How can it be done? The oxygen diffusion can be slowed down by adding zinc, nickel or magnesium salts to the environment. These salts react with this OH minus and forms insoluble hydroxides onto the cathodic surface. So these type of insoluble hydroxide layer is formed onto the cathodic surface, and this hydroxides act as the self barrier for the oxygen. So due to the presence of these type of hydroxides, again oxygen cannot reach to the metallic surface and this reaction would not be possible. So in the neutral solution or the neutral or basic environment, the cathodic reaction can be minimized by eliminating of oxygen from the surrounding environment or slow down the diffusion of oxygen to the metallic cathodic part. To eliminate the oxygen from the surrounding environment, we can use de-aeration method or we can use the reducing substances like sodium sulfide, etc. And to decrease the diffusion of the oxygen to cathode, we can use different type of metallic salts like zinc, nickel and magnesium. These salts basically reacts with the hydroxyl ions and form the hydroxide salts layer, which is deposited on the cathodic surface and prevents the oxygen attack on the cathodic surface. So further corrosion will be decreased. So I hope it is clear to all of you now. Now it is time for the revision. We are starting today the topic corrosion control, in which three important methods we have discussed: appropriate designing, modification of environment, use of corrosion inhibitors. In the appropriate designing, we have discussed that first precaution should be taken that avoid direct contact between two dissimilar metals. If it is unavoidable, the direct contact is unavoidable, then the metals should be selected in such a way that their electrode potential difference is minimum. Secondly, the anodic metal should be large and the cathodic metal should be small. Thirdly, proper insulation should be used between the two dissimilar metals to avoid the corrosion. If a single metal is selected, then it should be in the purest condition. Thirdly, proper air circulation should be there around the metallic structure, and welded joints are always preferred rather than using the bolts. Then we have discussed the modification of environment, in which we have discussed the 3 D's: de-aeration, deactivation and dehumidification. Then we have discussed the corrosion inhibitors. The corrosion inhibitors are two types: anodic and the cathodic inhibitors. Anodic inhibitors basically slow down the anodic reaction. These are of two types: anodic inhibitors. First is the inorganic anodic inhibitors and second one is the organic anodic inhibitors. Cathodic inhibitors are those which are used to inhibit the cathodic reaction. Cathodic reaction is medium dependent reaction. Therefore, in acidic medium, different type of cathodic inhibitors are used, while in basic medium, different type of cathodic inhibitors are using. Okay. Now it's time for the learning check. Read the question. What is the main drawback of using the anodic inhibitors and why it is considered as the drawback of the using anodic inhibitors? Think for this question, think for this topic, use the concepts which we have learned in our previous classes, and the detail of this answer the detailed answer will be discussed in the live class tomorrow. Okay. Till then, take good care of yourself and keep enjoy e-learning at home. Thank you.